Welcome to the REWIRE expert interview series in which we talk about security within IoT environments in the context of zero trust systems of systems. REWIRE as a Horizon Europe project has as a main objective to provide a holistic framework for continuous security assessment and management throughout the entire life cycle of IoT devices under the zero trust concept. My name is Christiana Kiperunda from 8Bells, one of the partners of the REWIRE consortium, and I am delighted to introduce our expert for today, Professor Liqun Chen from the University of Surrey, one of the technical partners of the REWIRE project. Welcome, Lee, and thank you very much for joining me today.
Thank you. Thank you, Christina. Thank you for having me here.
So let me start with our first question. In REWIRE, the use of trusted computing, including a trusted execution environment, is a core building block. Could you explain what are the core properties offered by these technologies for enhancing cybersecurity? Why such secure elements are considered as fundamental elements for cyber resilience in next-generation networks?
Thank you. For this question, we all know the TEE is an isolated environment, and from crypto point of view, we called it a crypto processor. So for the security, cyber resilience, next generation security, any security is based on cryptography. So we not only need to design cryptoware, but also implement cryptoware. That's very important. TEE provide an environment allowed us to implement crypto functionalities in a secure way. Compare with the software solution, compare with a purely hardware solution like TPM, TEE actually provide a more flexible choices, allow the user to create their own environment to put their functions in. That's why we choose TEE. That's why we think this is a good fundamental technologies for the project.
In this context, could you elaborate on how REWIRE uses such modules for enhancing the trustworthiness of a system? For instance, the project investigates a new set of zero-touch provisioning schemes for enabling the automated secure lifecycle management of a device, from its secure onboarding to its runtime attestation and update. What such protocols are and how they can safeguard the behavior of a system comprising multiple components?
In this project, we have a unique things to provide the attestation services in a very complete way. Because trusted computing, fundamentally, this is just to provide attestation service. Attestation service means you can attest every entities all the way around, start from beginning to the continuous. Zero-touch onboarding allows the connected device to be configured in the manufacturing line, then later on to be plugged into the service. When the device is plugged into the service, of course, it needs to be attested. So we use TEE. That attestation is carry on. It's not just from beginning. It is runtime. It is the dynamic, and also that is including the patching. If anything is going wrong, and the problem can be solved without stopping the whole systems. So that's why we think this the zero touch onboarding, zero touch the provision with the attestation service is the best protocols we can think about.
course, one core pillar enabling the secure lifecycle management of devices is the provision of crypto functions for addressing various security concerns that may arise during onboarding of a device, but also for trust-aware continuous authentication and authorization. As part of REWIRE, you are actually researching more lightweight crypto primitives for enhancing the security as well as the privacy of devices and data sharing. Tell us about how all these technologies come together and the type of research you are doing in the project in this front.
Okay, that's an interesting question. All security functionalities in the REWIRE project is based on cryptography, as I mentioned before. Surrey's contribution is to design crypto protocols or to identify suitable crypto protocols algorithms for the project. In the cryptography design, there are numerous challenges and numerous things which is tricky. Lightweight is one of them, that is performance, because crypto is quite cost. We need to constantly think about choose the best, most efficient protocols. But also we need to consider other properties like privacy. Privacy and security, sometimes they are conflict to each other, and privacy itself is also quite a cost. So our target in this project is we need to design the more efficient crypto, which is also privacy preserving. And privacy preserving means keep authentication at a station, but also let user be hiding in the system, not reveal their own identities and not against their privacy.
So based on the above, it becomes apparent the importance of security mechanisms as part of the overall hardware security. In general, how do you think that REWIRE solutions can impact the overall industry, targeting the deployment of heterogeneous devices as part of safety critical infrastructures?
Trusted computing technology has been there for many years. Personally, I have been involved in trusted computing researches over 20 years. Although trusted computing, we have a standard, we have a TPM, TE, DICE, and I can list very long the technicals. But actually, how to use those technologies in the real world and how to use it by industry, this is still a bigger gap. This project is trying to fill in the gaps and to demonstrate we actually can use trusted computing technology to solve real world problems. So we took the how to holding the system together, attest every devices, and make those attestation services in the runtime, dynamic. That is all to show the world trusted computing is ready. You can use it. That's, I think, is a bigger project contribution.
Are there any expert bodies or standardization activities with which you are working together and you are planning to present the outcomes of your research?
Yeah, this is a very good question. Actually, I'm very happy you asked this. I have been involved in a number of standard bodies, and I know other partners are involved in some standard bodies. Overall, we actually cover quite a good landscape for the standardization. Personally, I have been involved in TCG and ISO IEC and IETF. So we contributed to those standard bodies. I have been attend the TCG meetings and ISO-IEC meetings very regularly. I got a reward, like this is a TCG, TCG clothes, and that is a gift from the TCG meeting.
That's great, Lee. So I'm moving to the last question for today's interview. There is an interesting concept emerging nowadays about sustainable security with longevity. How the technologies of REWIRE can help towards sustainable security? Is it enough considering also that quantum computing is coming?
Yeah, that is also very timing correct questions and a very good one. Sustainable security is challenging. Security itself is challenging as well, but sustainable security is even more demanding. From my point of view, sustainable security means you need to keep a system secure, regardless whether your current crypto algorithms only have a short lifetime. Every crypto algorithms, their lifetime is limited, no matter how you design a crypto, because the computer power is carrying on to increase, and like a giant computer, quantum computer, this type of powerful machines coming, it will attack many cryptos we currently use. So that's why we need to constantly prepare ourselves to meet the requirement for sustainable security. Today, we got to face the challenge from quantum computer. We need to prepare our cryptos be able to keep secure against the quantum computer attack. So that's what we call the post-quantum crypto. So we are busy working on post-quantum crypto right now.
Thank you very much, Lee. Thank you for joining me today. Would you like to add something last for REWIRE? Something you want to mention about the REWIRE project?
Yes, I think REWIRE project is quite is very close to touch the real world, which I understand. I have been involved in 6 European projects so far, and every project, of course, have the unique features. And the REWIRE project, I think, is one of them, the most close to end world's life. So I like it very much. And also we have very good team, and I'm happy to be part of this.
Thank you. Thank you very much for joining me today.
Thank you, Christina. Thank you.